Hello and welcome to the Screencast introducing what a logarithm is. Because any exponential function of the form f of t equals b to the t, where b is greater than 1, is always increasing, the function's graph passes the horizontal line test, and thus the function has an inverse function. Because of this, we know that there's another function g whose process undoes the work of the given exponential function. For example, if we consider the base 2 exponential function x equals p of t equals 2 to the t, we know that there's a corresponding inverse function q with the property that q of p of t equals t. We use the notation t equals q of x equals logarithm base 2 of x to denote this inverse function. And notice that we read this, the logarithm base 2 of x. A good way to think of logarithms is that they tell us the power to which we should raise a base to get a desired number. For example, since 2 to the 4th equals 16, and the log base 2 function undoes the work of the 2 to a power function, it follows that the logarithm base 2 of 16 equals 2 to the 4th. Indeed, because an inverse function offers a different view of the relationship between input and output, we note from the outset that it's important to see that the logarithm base 2 of 16 equals 4 and 2 to the 4th equals 16 both say the same thing, just from different perspectives. The logarithm base 2 of 16 is the power to which we raise 2 to get 16. In this section, you'll learn more about both base 10 and natural base e logarithms and begin to see how logarithms are useful for solving equations where the variable is present in an exponent.